Okay, so we are live again. Since the 280, we are going to be treating some common questions, some frequently asked questions. Okay, some hot questions. I call them hot questions. Call them hot array questions. Hot array questions. Okay, so these questions tend to be like repeated questions over the years when it comes to arrays. Now, they actually all right, so they're actually not complex questions, but if you don't know them, you don't know them. All right, you don't know the answer to them, you will not know the answers to them. It's just basically you having knowledge of them. And in the last live class, I took my time to clearly explain the concepts. Okay, to clearly explain the concepts. All right, so basically, we are going to be looking at each of these questions, and I'm going to be explaining them one after the other. All right, for you to actually get it clearly and for you to understand it. All right, so now you can see questions here. Okay, now this is actually an array. This is actually an array dimension, and we have different arrays here. We have this. We have our 4 arrays. Okay, the first array is jcomp, has 6,8. The second array is schem, has 2,000 in it. The third array is psb 3,2. The fourth array is name, then has 60 in it. So now we're going to be treating the questions one by one after the other. Okay, one after the other. Okay, now if you look at the first question, now take a good look at this. So I believe they are clear, right, for you to see. Now the first question is the name of the third array. There are 10 questions here. All right, so these are 10 hot questions that you most likely see in exam settings. Okay, so there are 4 arrays here of the same dimension. The dimension here, the data type is integer. Okay, so now the name of the third array is dash. Okay, now if you look at the first array is jcomp. The second array is schem 2000. Third array psb. Fourth array name. So now if you look at the third array, this is the third array. So the third array is, the name of the third array is dash. This is the name of the array. Please don't confuse name of array for dimension of the array. Okay, or type of the array. If they don't say type of array, don't confuse it for name of array. The name of array is the array name. For instance, now this first array, the name of this first array is jcomp. The second array is, the name is schem. The third array is psb. So the answer that is supposed to be here is psb. Okay, so the third array, the name of the third array is what? psb. The name of the fourth array is name. Okay, so don't confuse the name of an array for its type. Don't confuse the name of an array for its type. They are not synonymous at all. When we're talking about type of arrays, we are talking about the one-dimensional array, talking about the two-dimensional array, we are talking about three-dimensional, multiple dimensions of arrays. But now in this case, when we say name of the array, we're talking about the array name. Okay, we're talking about the array name. So the name of this array, the third array, is psb. Now let's move to the second question. Say, what type of array is the first array? What type of array is the first array? Now look at the first array is jcomp. Okay, how many dimensions are here? There are 2 dimensions. So it means that the type of the array is a two-dimensional array. Okay, so that's the type of the first array. It's a two-dimensional array. Okay, it's a two-dimensional array. So this second one here is a one-dimensional array. Remember, I told you that in a one-dimensional array we have rows, so it means that there are 2,000 rows here. In a two-dimensional array we have rows and columns, so it means that we have 6 rows and 8 columns. Okay, and 8 columns. Okay, so that is it. Now moving forward, now the C part here, how many elements does the first array have? How many elements does the first array have? When we talk about how many elements, the number of elements in an array, total number of elements in an array is called the size. Don't forget that. So they must not necessarily say what is the size of the first array. So if they say how many elements does the first array have, what they're actually asking is for you to state the size of the first array. And I told you that if you have something like this, let's say this j comp, let's say that this j comp was 6 column 8, this 6 8. What this means is that this colon sign, okay, means that this is a lower bound and this is an upper bound. In this case now we would say 6, 7 and 8, and whenever we have just one column, here, it's a one-dimensional array. For instance, now if this j comp were to be, let's say 6 8, okay, then comma 4 7, this is a two-dimensional array because we have two dimensions. This is one dimension, this is another dimension. But anything that has to do with comma, okay, let me finish this one. Now this one now is the number of elements here, that is the size here. They just counting from 6 to 8, so the size is 3. So in this case you just count from the lower to the upper. How many? 6 7 8, that is 1 2 3. In this case now, what do we do? We get this the size of this one, and we get the size of this one, then we'll multiply. So now what do? In this case now, 6 column 8 will be 6 7 8, while 4 column 7 will be 4 to 7, 5 6 and what? 7. So how many values are here? 3. How many values are here? 4. So what do we say? We say 3 times 4, that will give us 12. So the size of this one is what? Is 12. But now that's not the question. The question now is the one that have comma. This one that has comma. So it means that now the main one, which is j comp, then we have 6 8. The fact that we have this comma automatically implies that we have to multiply. So this will be, to get the size, to be 6 times 8. Okay, 6 times 8, which is 48. 6 times 8 is 48, right? So it means that there are 48 what? Elements. It means there are 48 elements. Please don't forget that the size and the elements, they mean the same thing. So how many elements are here? 48. All right, there are 48 elements here. Okay, but for instance now, this PSB now, there are 6 elements because the size is 3 times 2, 6. All right, the size is 3 times 2, that's 6. Okay, so it's very important to note that. Okay, then for a one-dimensional array like this, the size is 2000, and then this one, the size is 60. Okay, size is 60. So now moving forward, say how many rows does the second array have? This is the second array. Okay, then the second array is a one-dimensional array, so you know that the one-dimensional array has only rows. So it means that how many rows? There are 2000 rows. 2000 rows. 2000 rows. If for instance now that came you're seeing there, if for instance this guy here, this came, we are to be let's say came 2050. Okay, this will be 2000 rows and 50 what? Columns. 50 columns. That's what it will be. The first value is your rows, the second value is your column, or the first dimension is your rows, while the second dimension is your columns. All right, so I believe that's clear. Okay, so now moving forward, now let's move to E. Now E says how many columns does the first array have? This is the first array. Remember, we are saying the first one is row, the second one is columns. So how many columns does the first array have? So the first array has 8 columns. The first array has what? 8 columns. Okay, I believe this is clear. The first array has 8 columns because this is the first array, this is the second array, this is the third array, this is the fourth array. Okay, so in exam settings they can give you arrays, lots of arrays, and they will start asking you questions like sub questions based on the arrays that are given there. So now, like I said, if you look at this first array, they are asking that how many columns does the first array have. Like I said, the first dimension here, which is 6, is the rows, while the second dimension is the columns. All right, so before we proceed, can you hear me? I want to be sure that you can hear me. If you can hear me, say I can hear you, sir. Type I can hear you in the comment box. You can hear me clearly, and you can see my screen as well. So type I can hear you if you can hear me clearly. Type I can hear you. Okay. I need more responses. I can hear you. If you can hear me, say I can hear you. So we'll proceed. All right, good, beautiful. Now let's proceed. Now for the next question, say what is the extent of the third array? What is the extent of third array? Now I told you that array is the number of elements along a dimension. Don't forget, an extent rather, is the number of elements along a dimension, which means that extent is like size. But extent is for one dimension. An extent is for what? One dimension. Why is size is for more than one dimension. Size can actually be one dimension too. Okay, like for instance, now the size here is 2000. Okay, the size here is 2000. The extent is also 2000. So one thing you need to understand is that extent is for only one dimension, but size is for from one dimension and above. Size from one dimension. So an extent and a size are they actually the same, but an extent is for a one-dimensional array. So now for instance now if you look at this jcomp now, the extent here is 6 and 8. That is the extent to the extent of the one dimension here is 6. If they ask us what is the extent of jcomp, the extent is you say there are two extents here. The first extent is 6, you write, then the second extent is 8. Now what is the extent of this? Extent of this is just 2000. So we say an extent is the number of elements along a dimension. A means one, along one dimension. The number of elements along one dimension. For this PSB now, the extent here, there are two extents here. The first extent is 3, the second extent is 2. The extent here is just 60. But when we talk about size has to do with both extent and more than one. That is both one dimension, two dimension. For the size here is 6, but we cannot say what is the extent of 3 and 2. No, rather extent is one dimension, another dimension. What is the extent of the first dimension here? 3. What is the extent of the second dimension here? 2. But what is the size of this array? 3 times 2. There's nothing like extent of the whole array. Rather, we have extent of the dimensions inside the array. This is the first dimension 3, second dimension extent 2. First dimension extent is 6, second dimension extent is 8. If it's 3 dimension, it means that we have 3 extents. When you want to calculate extent, don't multiply everything inside. So it's wrong to say the extent is 6 times 8, which is 48. It is the size that is 48, not extent. I believe that's clear. All right, so it means that the extent of the third array, which is this is the third array. This PSB 3,2 is the third array. So the extent now, we would say for PSB 3,2, now extent. What is the extent? Now first dimension is equal to 3, while the second dimension is equal to 2. First dimension is 3, while the second dimension is 2. All right, so don't forget, an extent is the total number of elements along a dimension. So it talks about a dimension, but size can be for the 1 dimension, 2 dimension, 3 dimension, and all of that. All right, so that is it. Now moving forward to the next question. See, it says the shape of the array d comma 4. Now we are no longer working with this with these arrays again. Now we are working with new arrays. So now you say the shape of the array d bracket 4 comma 6 is dash. I told you that the shape is actually what is inside. The shape is what is inside the array. It's just bringing, when we say what is the shape of this object, you will just see the shape is just represented by how the object looks like. Physical representation of that object is the shape. Say someone's shape, how the person looks physically. All right. So the shape here, so the shape is just simply bringing out what is inside. So shape is 4 and 6, or we can just say 4 comma 6. That's the shape. Shape is just to bring out what is inside, and what is inside is 4 comma 6. So that's the shape. Okay, in fact, it's best to say 4 comma 6, 4 comma, let's just use comma, 4 comma 6, which is this. All right, so the shape of this array is what is inside. Just bring out what is inside. That is the shape. Okay. All right, now moving forward, let me use this one as an instance. Now, what is the shape of this jcom? The shape of this jcom is 6 comma 8. What is the shape of psb? 3 comma 2. What is the shape of chem? 2000. What is the shape of name? 60. All right. So that's for shape. Now moving forward now to the next one. Say if an array is declared as f bracket minus 3 colon 2 0 colon 4. I told you that these colons here are used for lower and upper bounds on the number line. It means that if we have minus 3 colon 2, it means that it is from minus 3 to 2. If we have 0 colon 4, it means that it's from 0 to 4. That's what it means. That's what it clearly means. All right. So basically, if an array is declared as this, its size is dash. So what is the size? Asking us what is the size of this array. Now I explained earlier, and I'm going to explain it again. Now, if you look at this now, basically when you have this like this, see, minus 3 comma 2 is different from minus 3 colon 2. They are different. Okay, minus 3 comma 2 is different from minus 3 colon 2. This one you're seeing here is 1 dimensional. This one you're seeing here is 2 dimensional. Anytime you see colon, in fact, if it like, let it be minus 3 colon 2 colon 7, it's still 1 dimensional. What is that? Minus 3 to 2 and 2 to 7. So it means that this one now will be minus 3 minus 2 minus 1 0 1 2 3 4 5 6 7. That's what it means. So it's still 1 dimensional. The only thing that makes an array more than 1 dimension is the use of a comma. It's when you're using a comma sign. That's what makes an array more than 1 dimension. So in this case now, you know that if we had comma here, we'll just do minus 3 times 2, which will give us minus 6, right? But now when we have something like this, now basically what do? Simple. We now outline the values that moves from minus 3 to 2, which is minus 3 minus 2 minus 1 0 1 and what 2. Then the second dimension here is from 0 to 4. So we say 0 1 2 3 and what 4. So now we count the number of values and multiply them. How many values are here? 1 2 3 4 5 6. So there are 6 values here. How many are here? 1 2 3 4 5. Why there are 5 values here? So 6 times 5 will give us what? Will give us 30. So the size is 30. Size is simply 30. All right. So that's how to navigate size. That's how to navigate size. All right. That's how to navigate size. So basically, one thing we need to understand is that When we talk about size, okay, when we talk about size, if we have a three-dimensional array, for instance, it means that there will be three dimensions inside. All right, to get the total number of elements, we would multiply exactly as we multiply two dimensions. The same way, similarly, we multiply the same way. Okay, now moving forward. Okay, now let's look at I. So the question is, what is the shape of the array? What is the shape of the array integer x minus 2 colon 3 0 colon 4 1 colon 5. Okay, so the shape of this array is simply exactly what is inside here, which is minus 2 3 0 4 1 colon 5. And this is of course a three-dimensional array. Don't forget that this is a three, because this is one dimension, the second dimension, the third dimension. So this is a three-dimensional what array, a three-dimensional array. So this is the shape. I told you the shape is just simply what is inside. So this is the shape of the array. Just bringing out what is inside is the shape. Okay, now the last one, if an array is declared as if an array is declared as h bracket 5 comma 4 comma 3, the rank is dash. So if you look at this, we have three dimensions inside, 1 2 3. So it means that the rank is 3, because it's a three-dimensional array, so the rank is 3. All right, so the rank is 3. So these are hot questions. They are like commonly asked questions, but like I said, now they may look simple, but like I said, they are simple now because you actually know them. Okay, anyone who have no knowledge of what rows, columns, size, shape, rank, extent mean, dimensions mean, then that person have not really studied arrays. Now I gave you something earlier to do. I don't know how many of you did it. I said you should tell me the size, rank, and shape of these arrays. Okay. Now what will be the size of this? Okay. Now first of all, the size of this is we multiplying everything. 4 times 3 is what? 4 times 3 is 12. Then 12 times 7. 7 times 2 14. 7 times 1 7 8. Good. 84. Okay, so it means that for the first one, the size here is 4 times 3 12. 12 times 7 84. So it means that the size is 84. Okay, I told you guys initially to write it in the comment box. You did not write it. Nobody said anything. In the previous slide, nobody said anything. To an extent, I even felt that I was talking to myself. I had to end that live because I thought that maybe you aren't hearing me. I had to end that live session. Let's be proactive, please. Let's be proactive. Okay, so now the size is 84. Now the rank for this one, the rank for this first one, this is a three-dimensional array, so the rank is 3. Okay, then the shape is just 4 3 7. That's the shape. I told you that the shape is what is inside. Okay, 4 3 7. Then for number 2, the size. Okay, I can see your response, Joy Okuli. I can see your response. Okay, keep it up. Now for this one, the size is, remember, these ones are using colons, which is of course the lower and upper bound. So the size will be from 2 to 5, 3 to 4, and minus 3 to 0. So 2 to 5 will be 2 3 4 5, right? 3 to 4 will be 3 and 4. Minus 3 to 0 will be minus 3, minus 2, minus 1, and 0. So if you check it now, this dimension has how many elements? 1 2 3 4. Has 4. This one has 2. Why this one has 1 2 3 4? So what do we say? We say 4 times 2 times 4. 4 times 2 is 8. Okay, 8 times 4 is 32. So the size of this second array is 32. The size is 32. Okay, then the rank it's also a three-dimensional array, so the rank is 3. Then the shape The shape is just writing what is there, which is 2 colon 5. Okay, 2 colon 5, then 3 4 and minus 3 colon 0. Okay, so that's it. It's simple, it's not difficult. All right, it's not difficult. All right, so that is that for array size, array rank, and array shapes. Okay, so I'm going to be explaining control structures. I'm going to be defining control structures, and also telling you how they are different from each other, how they differ from each other. Okay, control structures is also a very crucial aspect of Fortran that cannot be ignored. Okay, cannot be ignored. So going to be explaining control structures right away. Okay, all right. So now moving forward, like I said we'll be looking at control structures. Control structures. Okay, control structures. All right. So basically, when we say control structures, what do we mean? The words there are control and structures. Okay, so what are control structures? I'm going to be using keywords that will enable you to remember. Like I said, remember I told you how what arrays are. I use some keywords. I said that an array is an orderly arrangement. I use orderly arrangement. I use the similar objects. I use rows and columns. I use matrix. I use size. I use data type, and I use different values for you to actually remember what arrays are. That an array is an orderly arrangement of similar objects, often in rows and columns, in the form of matrix, whose objects are of the same size and data type, although the objects may have different values. That's what I said about arrays. So for control structures, I'm also going to be giving you some core principles in the definition, or from core key points in the definition that will enable you remember quickly. Okay, so now control structures are blocks of codes. They are blocks of codes. Okay, they are blocks of codes in any program. Okay, they are blocks of codes in any program that directs the implementation flow of the program. So those blocks of codes in any program that directs how the program should flow is what we call control structures. So there are blocks of codes in any program. It means that there is no program that will not have control structures. In any program that directs the implementation flow of the program. Okay, of the program. So we'll be talking about a couple of control structures. All right, so I'm going to be listing the control structures that we'll be focusing on. We'll be looking at the if statement. That's the first one. Then the second one we'll be looking at is what we call the if then else. If then else and if statement. If then else and if statement. Then we'll also be looking at what we call the nested if statement. Okay, this is the third one we'll be looking at. Then like I said, these are blocks of codes, don't forget that. All right, so then the last one we'll be looking at, okay, is what we call the case construct. The case construct. Okay, the case construct. So if you look at, I'm writing some in capital letter, I'm writing some in small letter. Okay, so the name of the structure is, we have if. This one is if then else and if. This one is nested if. This one is the case, or just case. Okay, then we would also be looking at what we call loop control structures. All right, loop control structures. Okay, and these loop control structures are very, very crucial as well when it comes to Fortran. All right, so when we talk about loop control structures, they are called iterative, that is, they are repeated control structures that holds a program as long as the particular condition that has been given is valid. It may not make any meaning, but when I'm explaining it to you, you may read meaning out of it and you may be able to understand it clearly. All right, so now moving forward, for loop control structures, we are going to be looking at what we call the do loops. Okay, the do loops. All right, we're also going to be looking at another core aspect, which is the second one, that we call the do while loops. Okay, these are loops, what, control structures. These are the control struct these ones are the ones that are in form of statements. All right, why these ones are the ones that are in form of loops, that's why they are ending with loops. All right, then we also have what we call the nested loops. The nested loops. All right, nested loops. So these ones are the ones that falls under the what, if you remember, I said these ones falls under the loop control structures. Control. Okay, control structures. Loop control structures. Okay, why this one falls under what we call the statement control structures. Okay, control structures. Now both of them are what, control structures, but they are classified. These are for the statements, why these ones are for the loops. These are for the statements, why these ones are for the loops. All right, why these ones are for the loops. Now moving forward, we'll start with the if statement. Okay, we'll start with the if statement. Now, for if statement, it's very crucial to actually understand that any all these concepts we are talking about, you must write programs. Okay, there must be programs that will enable you to understand them better. Okay, there must be programs that will enable you to understand them better. But before we look at those programs, I'm going to be defining each of them. I'm going to be giving you the definition of each of them. I'll be giving you a definition of if statement, if then else end if statement, the nested if, the case construct. We have the do loops, do while, and nested loops. So I'm going to be defining all of them for you. So now, what is the if statement? So the if statement is a conditional statement which performs a logic according to a given logical expression. All right, so the if statement, I'm going to repeat that it is the if statement, like I said is a conditional statement. It's a conditional statement. All right, which performs a logic according to a given logical expression. So this is what an if statement is. This is a conditional statement, which means that this statement can only be used when there is a condition attached. Remember, I said that control structures are blocks of codes that directly implement the flow of a program, or that directs the implementation flow of a program. So for this particular if statement, there have to be a condition that is attached, and this conditional statement must perform a logic according to a given logical expression. So, and if you look at it very well from this definition, two things have to be given: conditional statement and logical expression. So it's a statement that will facilitate the performance of this logic. All right, it will facilitate, so it would help in performing this logic, but it will be based on the logical expression that is given. So that's for if statement. All right. So now if you look at it now, you realize that number two, we also have what we call the if then else and if. All right. If then else. We have the then else, if then else, and if statement. If then else and if statement. Okay, it can be a mouthful, it's a long one. All right, but the most important thing is to actually know what it means. All right, so remember I said that for if statement, it's a conditional statement which performs a logic, and this logic must be performed based on the logical expression that is given. Remember I talked about logical operators like true, dot false, dot not, dot and, dot or. Those are logical expressions. Okay, so now the given logical expression that would be present is what will back up the performance of the logic. Okay, but the conditional statement is what will perform that logic. Now moving forward, now if then else and if statement, the if then else and if statement is actually a control structure that allows an additional option. It allows an additional option to the if statement, an additional option to the each if what statement, which makes the construct to be more flexible. Okay, so this one makes what the construct, that is the control structure, to be more flexible. All right, to be more flexible. Okay, so when you have a condition, if somebody says, okay, I want you to do this, I want you to clear the backyard, else you would not be paid. If you look at it very well now, you realize that there is an additional option here, which is what? Else. Which is else. So else now makes the construct to be more flexible. So now you will now realize that if I now say I want you to clear the backyard, else you will not be paid, what will happen? The fact that I said you will not be paid will make you to what? To clear. So what happens is that the presence of this else makes this if statement to be quickly performed. The logic in this if statement now will be quickly performed because there is now an additional option, which is the else. So it allows an additional option to the if statement, which makes the construct to be more what? Flexible. Keyword here, flexible. So it provides flexibility to the if statement by virtue of the presence of this else. Okay, so else makes it faster, like I explained. If you tell someone to sweep and you say, okay, if the person does not sweep, that person will not be paid. Say else, you would not be paid. Now the else there is what will facilitate. I don't want to be old though, I want to be paid, pap, and you realize that the person will be very fast to actually perform that action. So if then else and if statement, we can say that it supports and it mediates or it facilitates the if statement. It makes the if statement to be easier to perform a logic. All right. So can you still hear me? If you can hear me, say I can hear you, so we can proceed to the next one. I'm going to be explaining all of these control structures. So I'm going to be defining all of them for you to understand them. So we have done this. We have done if statement. We have also done this. All right. So if you can hear me, say I can hear you, sir. Type I can hear you in the comment box. So we'll proceed. I'm waiting for your response. If you understand, say I understand. I understand clearly. That's if you understand. If you don't understand, don't type. If you understand, say I understand. I understand clearly. Waiting for your responses. All right. So I can see your response is good. So let's proceed. Now the next one here, okay, the next one here is nested if statement. Okay, the next one here is a nested if statement. So now nested, nested, nested if statement. That's the third one. So what's a nested if statement? So a nested if statement, when you say nested, we are talking about putting something into another thing. All right, a nest. So nested if statement is actually a statement in which an if statement is a statement in which an if statement is embedded in in another if statement. Okay, so when an if statement is in another if statement, it's called a nested if statement. If statement is embedded in another if statement, it's called the nested if statement. So it means that an if statement that is two in one, this if statement here, carrying if statement and putting in another if statement, okay, makes it a nested if statement. Okay, so that's what nested if statement means. All right, then the next one is the case construct, which is this one. All right, this one, the fourth one, which is the fourth part of the statement control structures, is the what case construct. All right, the case constructs. So the case constructs, the case construct. So when we say case construct, what do we mean? So case construct is actually a control structure, okay, that is used to limit excessive use, okay, excessive use of the else, the else statement, okay, the else statement. So it's used to limit excessive use of the else statement. It's just like a controller, okay. It's just there to like try to control or to recommend a pattern, okay, recommend a pattern through which this else will not be excessively used. It is there to, just like a resistor, okay, just like a resistor, okay, which controls the amount of current that flows into a circuit. All right, that controls the amount of current that flows into a circuit. That's how a case construct is. Now, okay, but let me just use a real life example to explain this further. Now someone can come here, okay, and meet someone else and say, okay, see, like I said, I said earlier, if you don't clear the front yard or the backyard, you will not get paid. And that person is using that you will not get paid, else you will not get paid, else you will not get paid, using it to threaten the other guy. Okay, what do you think the person is doing? The person is excessively using the else statement. So now then another person comes and say, what you are telling this guy is not good, you are intimidating him. So because he is working and he's working tirelessly, you feel that you can intimidate him with your money bar and all of that. You feel that you can intimidate him with your money, and it's not a good thing. You're making him feel so bad, you're making him feel terrified, you're making him feel less of himself. Now, do you know what that person is doing? The person is limiting the excessive use. Please, I don't want you to do this, please, it's not good. Do you know what that person, the person who was probably saying else you will not get paid, from that particular statement that this other guy have made, if he wants to change, he can actually stop using that else you will not get paid. Okay, if he was actually saying it every day, maybe he can just come once in a week and say it. So one thing about this else statement is that, okay, when it is limited, it is not entirely removed. Okay, it's not entirely removed, just like the guy will not entirely stop saying else you will not get paid. The else statement is not entirely removed, rather it is limited. So the regular use and the excessive use of the else statement would not be as it was before. That's what the case construct does. That's basically what the case construct does. All right. So now moving to, let's look at loop control structures. Let's look at loop control structures. So we have do loops, we have do while loops, and we have nested loops. All right, we have do loops, we have do while loops, and we have nested loops. So we'll be looking at do loops first. Okay, looking at do loops first. So from the word loops, like I told you, loops are like repeated control structures or iterative 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 control structure that it more like it goes, you know how loops are now. Okay, they go from one step to another, step 1, step 2, step 3, step 4, step 5, step 6, like that. Okay, so they are called iterative control structure that holds as long as a given condition is valid. Now a condition will be given. Remember we said that there are blocks of codes that what directs the what implementation flow of a program, which means that provided that the condition that is given in that particular control structure is valid, do loops would, or loop control structures rather, would continue holding, or will continue running. So a loop allows us to actually execute a statement multiple times. All right, it allows us to execute a particular statement as many times as possible, provided that that condition is still valid. All right. So basically it is actually subject to conditional validity. Okay, it's actually subject to conditional validity. So what happens in do loops? So do loops is actually a construct that enables a statement or series of statements to be executed while a given condition is true. Okay, the do loops allows a statement to, or the statement or series that is several. So we say it allows a statement or series of statements to be executed. When we say to be executed, we are talking about to be performed, to be executed, provided that the condition is true. Okay, so provided that the condition is true. So this is like the basis of loops. Okay, so provided that condition is true, the statement will be executed as many times until the condition is no longer true, until the condition is false. So it works with logic. Control structures work with what? Logical expressions. So provided that particular logical statement or that logical condition is true, then that particular statement will be executed as many times as possible. But once it becomes false, once it's no longer true, the statement will no longer be executed. That's what we call the validity, conditional validity, or the validity of the condition. All right. So that's for do loops. Now moving forward, we have the do while loops. We have do while loops. So when we say do while loops, what do we actually mean? Okay, from the word do while loops, now you realize that while is being added. Without while, we just have do loops. So now what does do while loops do? So now the do while loops, let me write it. So do while loops constructs. Okay, do while loops constructs repeats a statement or group of statements. Repeats a statement or group of statements while a given condition is true. While a given condition is true. Now basically you may be wondering, what is the difference between do while loop, okay, and do loops? Because now if you look at it now, it's as if we are repeating the same definition. Now we say, look at it too. We say do loop is a statement when a statement or series or statement are executed provided that the condition is true. So provided that the condition is true, as long as the condition is true, it will be executed, right? Now, so the execution for do loops, for statements, would only stop when the next statement wants to start execution, and they now realize that in the program the condition is false. Because it's just like you starting one, you want to execute one statement now, one, you execute it to the end. Though at the beginning of that one, at the beginning of the first statement that you want to execute, you realize that the condition is true. What will happen? It would continue till it ends. Even if along the line the condition is no longer true, that particular statement would run till the end, will be executed. But now when you want to enter the second, you want to run the second, now at the beginning of trying to run the second for do loops, the do loop will not be executed. The statement will not be executed in do loops, because when you wanted to begin the second statement, what happened? You now realize that the condition is no longer true. Then it will not be executed. But do you know one thing about the do while loops? The do while loops is that even when that particular statement has started execution, and along the line it is realized that the condition is not true, it will not even end. That particular loop will not even end. It will just stop. But for a do loop, it will continue until it has been executed. But that's why we say while a given condition is true. So as long as the condition remains true, that particular statement will be executed. Now let me use another example that will be clear. Now let's say a man is driving a car. Let's say a man is driving a car. Okay, a man is driving a car from one point to another. Okay, now this car is going from one point to another. Now, and why the man started the journey, and someone called the man and say, "Hey, Afana, come back, where you dey go, you no go see wetin you dey find. Where you're going to, you will not get what you're looking for." And the man had already started the journey. You know, some people will say, don't worry, I've already started, let me just reach there first. Okay, now at the time that he started this journey, he was told that where he's going to, he will get what he wants, right? But he started the journey and he was going, and along the line he got an information that where he's going to, he will no longer get to, that he should come back. Then he says that they should not worry, that he wants to he have already started, let me just get there at once, that he should just get there at once. So this is what the do loop does. The do loop would ensure that the statement is executed provided that the condition is true. Okay, it will start the execution. It will start the execution process. Okay, but for do while, as long as the man has gotten the information that particular place is going to, he will no longer get what he's looking for. He will just stop at that point, so he will not go to that place. Because that's why we say while it means that along the line, while the statement is being executed, the loops will not be complete as long as along the line the condition has been seen to be false. As long as along the line the condition has been seen to be false. So when do while loops work with present continuous tense. That's what do while loops. Do loops work with future tense. Once a do loop have started, it will continue like that until the execution, until the final, before it starts another loop. So before it starts another loop, it must have confirmed that the condition is true before it starts execution. But here, while it's being executed, why, that's why it's called while it's being executed, if the given condition is no longer true, that particular what loop will not repeat itself, it will just stop. That particular loop will not repeat itself, it will just stop. Okay. So that's for do while. Now let's look at nested loops, which is the last but not the least. So now what are nested loops? So a nested loop is, okay, let me write it down. Okay, so we have nested loops. Okay, so when we say nested loops, what do we mean? So a nested loop is a loop that, so a loop, say a loop that is embedded. When you, anytime you hear the word nested, know that it has to do with embedding. A loop that is embedded in another loop. Okay, another loop. So most times nested loop, the major function of nested loops is to manipulate arrays. That's the major function of nested loop, to manipulate arrays. So like I say, nested loop is a loop that is embedded in another loop. So when even if it's a do while loop, if a do while loop is inside another while loop, it's a nested loop. If a do loop is inside another do loop, it's also what, a nested loop. All right, so a nested loop is actually a loop that is embedded in another loop. So when a loop is in another loop, it's called nested loop. All right. So basically that's all. Okay, so don't forget I said if statement is a conditional statement that performs a logic according to a given logical expression. If then else, this one is when there is an additional option, okay, to the if statement. When an additional option is added to this if statement to make it more flexible, that's if then else. Now the nested if is when one if statement is in another if statement. Then case construct is actually a control structure that is used to limit excessive use of this else, of this if then else statement is used to what, limit excessive use of it. Then I told you that a loop is actually defined as the iterative or when you say iterative, you're talking about repeated. Okay, iterative control structures that what holds as long as a given condition is valid. When we say validity, we are talking about true. As long as the given condition is true, that is what loop structures. That's what happens in loop. So the statement will be repeated over and over until when the loop structure has seen to have a conditional validity that is false. All right, and so that's for loop. Then we say do loop is actually a statement or series of statements that is executed provided that the condition is true. But do while is while the condition is true. All right. Then now nested loops, we say that it's when a loop is actually embedded in another loop. All right. So I want you to stick to these definitions, have them in your memories. Don't forget that control structures are blocks of code, any program that directs the implementation flow of the program. All right, don't forget that. So this is the basic definition of control structures. This is basic. When it comes to control structure, this is the basic definition of control structure. So in the next live video that will begin shortly, we'll look at examples of programs for each of these control structures. We'll be looking at examples of programs for the if statement, how the if then else and if statement looks like, how the nested if statement is run, how the case construct is run. We'll look at do loops, look at do while loops, and we'll look at the nested loop. All right, if you're not subscribed to this channel, do well to hit the subscribe button so you would always know when we are having a live class or the other, one live class or the other. Okay, hit the subscribe button. Whenever you see a link as regards to a live class, share to those persons who will find it beneficial. All right, no knowledge is a waste. All right, keep learning, keep growing, keep improving, keep developing. All right, okay, so I'll be ending this class right away. Okay, goodbye and see you in the next live.